This is the Algebra 1 Summer School Unit 5 Lesson 3 notes video on factoring difference of squares. Alright, so the difference of squares is a very special factoring case. It happens when you start with a binomial. A binomial has only two terms. So if you look through the notes, all of these problems only have two terms to them. Okay? So what's special about these two terms is they're both perfect squares. A perfect square, I'll write that down, a perfect square is a number that you can take the square root of. So here's the pattern. It says a squared minus b squared equals a plus b times a minus b. Now, the way we get the a and the b on this right-hand side is you take the square root of each term. Well, the square root of a squared would just be a, and the square root of b squared is b. That's where the a and the b come from for the right-hand side. Once you see this, you're going to catch on very quickly. So let's look at number 1. I have m squared minus 4. That's one thing I want to point out that I forgot to just above. This is called the difference of squares. And in difference in math means subtraction, minus. So it only works because all of these have a minus sign in the middle. If there's a plus sign, you cannot factor. All right, m squared minus 4. I start by taking the square root of each term. The square root of m squared and the square root of 4. Don't take the square root of negative 4, just the 4. Ignore the negative for now. The square root of m squared is m, and the square root of 4 is 2. So I'm going to use that m and the 2 in each factor. Now I'm going to have two factors here. They're both going to have an m, and they're both going to have a 2. One factor gets a plus, one factor gets a minus. Now if you wanted to check, because that's the answer there, if that's correct, you can distribute. M times m is m squared. M times negative 2 is minus 2m plus 2m minus 4. Well, notice the negative 2 and the positive 2 here cross off. They add and become 0. So I end up with m squared minus 4, which is what I started with. So m plus 2, m minus 2 is your final answer. All right, next, number 2. I again start by taking the square root. I'm going to take the square root of 49x squared, which is 7x, and the square root of 81, which is 9. So I'm going to use the 7x and the 9 in each factor. Remember, you're going to get two parentheses. Each gets a 7x and a 9 in that order. One gets a plus, one gets a minus. No, it does not matter if you wrote the minus first and the plus second. All right, last one in this row. Take the square root of 25x squared, which is 5x, and the square root of 16, which is 4. I use the 5x and the 4 to write my factors. I end up with 5x, I'll do the minus first this time, times 5x plus 4. Okay. Now you might be thinking this is a really easy factoring method, like I'm just taking the square root and putting them in. It is a really easy factoring method. The hard part is when it gets mixed up with everything else and you have to be able to identify what factoring method you're using. All right, so 16 minus x squared. Same type of problem, I can take the square root of 16 and the square root of x squared. I know that I can use this factoring method because there's a minus sign in all three of these problems. Well, the square root of 16 is 4, and the square root of x squared is x. I'm going to use the 4 and the x, but I have to use them in that order when I write them in my parentheses. It has to go 4 and then the x, 4 and the x, a plus and a minus. All right, number 5. I'm going to start by taking the square root of x squared and the square root of 1. That gives me x and 1, which become part of my factoring pattern here. Each parenthesis gets an x and a 1. One gets a plus or a minus, and one gets the plus. That's it. Remember, you can always check your work by distributing. Last one on this row, 100r squared minus 9. I start by taking the square root of 100r squared, which ends up being 10r, and the square root of 9, which is 3. I'm going to use the 10 and the 3 both in my factors. So I end up with 10r minus 3 and 10r plus 3. Again, as usual, you can FOIL or distribute to check. So let's check here. 10r times 10r is 100r squared. 10r times 3 is plus 30r. Negative 3 times 10r minus 30r minus 9. Well, these 30s and negative 30 cancel, and you're left with 100r squared minus 9, which is exactly what I started with, so I know I worked correctly. All right, last 3 problems on the notes. I have 27x squared minus 12. Okay. Can I take the square root of 27? That's what I have to figure out. Well, if I take the square root of 27 and put it in my calculator, I'm going to get a really weird decimal. Same thing with 12. I can't take the square root. So I have to think about what is the rule for when you factor something. Well, the rule we talked about in the first lesson is you always look for a GCF first. So when I look at 27 and 12, they actually both have a GCF of 3. I'm going to divide 3 from both of them. When I divide out of 3, I'm left with 9x squared minus 4. But now that I have 9x squared minus 4, it turns out that there's a minus sign in the middle, and I can take the square root of 9 and 4, which means I can now do my difference of squares. So I need to find the square root of 9x squared, which is 3x, and the square root of 4, which is 2. So I'm going to write factors here using that 3x and the 2, but I can't forget that I need to bring down this 3 into the front of my other factors. That 3 is a factor and it has to stay there. So then I can finish factoring this as 3x plus 2 times 3x minus 2. So that was a little bit more involved because I had to find a GCF first. All right, finally, 50 minus 98x squared. Same as the last problem, I can't factor by difference of squares yet. I think I'm going to because I have a minus sign here. Oops. But I can't take the square root of 50 and I can't take the square root of 98. So I start by looking for a GCF, which ends up being 2. When I divide by 2, I get 25 minus 49x squared. Well, now that I pulled out that GCF, I can take the square root of 25, which is 5, and the square root of 49x squared, which is 7x. Just like the previous problem, I bring down the 2 and then have my other factors as 5 minus 7x, 5 plus 7x. All right, last problem on the notes, then we'll do some practice. 36 minus x squared. It's good because there's a minus in the middle, so I can use the difference of squares, and I can already take the square root of 36 and x squared. So the square root of 36 is 6. The square root of x squared is x. So I can jump right in and factor this as 6 minus x times 6 plus x. That's your final answer. You could check it by distributing. All right, go ahead and try the quick 6 problems of practice on the bottom of this notes file. There's a key posted on Canvas as well as a video for that practice.